All right, so you guys have practice number 5 in your hands. Let's try to do number 1. It says, find the formula for the inverse. Let me give you 30 seconds. See if you remember anything. Formula for the inverse. Then I'll crank it out. What do you do? First, what's the first step? Yeah, that's a y. Right, good. F of x is y, so it's y equals 9. Yeah, you make that a y. And then what do you do? First, x and y need to switch. Then we'll do the cross multiply. You're right after that. Yeah. So the 2 steps for an inverse function, let me just write them out for you again. For inverse function number 1, switch or invert x and y, right? That's what inverse function means, is invert x and y. Switch x and y. Step 2, solve for y, which will, it'll be cross multiply. So I switch x and y, switch these two. So x will go here, y will go there. Yeah, that's right. Remember that? And then put this over 1, diagonal, diagonal, cross multiply. And that'll be distribute xy plus 8x is 9. Remember that? Is it coming back? So switch x and y. Solve for y. What do I get to do now to... Can you finish that up? Solve for y. So y is saying I want to be alone. Solve for y. So you just jump this 8. Hey, should I factor out the x? How about that? No, yeah, you're right. No, it's tempting though. A lot of people do it. Why not? How do you? Didn't I say there was some times when you factor? There are some times when you factor. Not here, not x. Why? Because they're not asking me to solve for x. If they were saying solve for x, find x. No. I'm not trying to find x. What am I trying to solve for? Y. So if there were 2 y's, I'd factor. You only factor the letter you're trying to solve. You don't factor other letters, right? Everybody good there? So you get xy is 9 minus 8x. Divide by x. Boom. 9 minus 8x over x?
Yeah, it's b.
Yeah, did everybody see that's b? It is the same. You're right. They just reverse the order, but the same signs. Is that good? I'll try number 2. So it's another inverse. Number 2 is another inverse. See if you can do number 2. Give you a little bit of time. So same thing on number 2. Switch x and y, solve for y. Switch x and y, solve for y. So number 2, y equals x cubed plus 6. So step 1, switch x, y. That's what an inverse function means, is invert x and y. So they trade positions. X is out here, y is over there. So switch x and y. Step 1. Step 2, solve for y. So yeah, good job. So subtract the 6. And then what do we do to finish getting y alone? Third rooted, right? And boom, y is alone. There it is, third root of x minus 6. C. Is that okay? Questions on that one? All is well? All right, on we go. Try number 3. Logarithms and all their properties. Squish those into one log by using the properties. All right, so we have 4 logs, added and subtracted. It's a big mess, isn't it? So the numbers that are in the front, where do they go? Like the 6 to where? Power zone, right? They're going to go up to the power. Remember, numbers in the front go to the power, back and forth. Remember that? Remember that property? Not so much? All right, that's the first step. Log base C m to the 6th minus log base C n to the 2/3 plus log base C j to the 1/6 minus log base C k to the 2nd. Good so far? I just took all those numbers that were in the fronts and stuck them in the powers. That good? The numbers that were in the fronts, and I stuck them in the powers. Okay, now what do you do from here? Well, added things go in the numerator, subtracted things go into the denominator. So this will be log base C. What do we got? We got, this is an m here, it's kind of scribbly. M to the 6th, and this is j to the 1. They both go on the top because they're both positive, and the 2 negative ones, n to the 2/3 k squared, go in the denominator. Is that what it is? Looks like it is. See, does that make sense on those rules? You see how I followed those properties? So numbers in the front go to the power. And then added logs go to the numerator, subtracted go to the denominator. Questions I can answer on that? No questions? We good? Okay, let's try number 4. Let's move on to number 4 if you've got that one down. Try number 4. All right, number 4. So same thing. Take those numbers in the front and put them in the power. Oops, which was 3? So is that good? So those numbers in the front went to the powers. Is that good to there? Numbers in front go to the powers. And then this becomes times, right? Adding for 2 logs becomes multiplying for 1. Remember that? So this is times.
Oh.
So there we go. Which one is that? It's is it D? Yeah, looks like D.
Yeah.
Does everybody see that? How that works? You comfortable with those properties? Remember the properties? Remember it's easier. Remember, like an easier job for 2 people, harder job for 1 person. Easier for 2, harder for 1. Like if I had something heavy, I was just talking to my friend whose table we moved maybe a month ago, And he says we may need to move it again. I'm not looking forward to that. So we had a whole bunch of people that moved a 700-pound table, right? It would have been impossible for 1 or 2 people to do it. So that's the kind of thing logs are doing, right? For 2 logs, it's just adding. Easy job for 2 people. 1 log, it becomes times, higher level operation, right? Times is higher than adding. Remember that? For the 1 log, it's the higher, harder operation. For 2 logs, or 3 logs, or whatever, it's just easy, add, subtracting. Right? We good? For 1 log, it's multiplying, dividing. Good? All right, want to go on to number 5? Making a little headway on this thing. D? Or 3? 3 was C. And all the answers are at the end of this document. You guys know that, right? On the online one, if you just flip all the way to the end, all the answers are there. If you want to check them over Thanksgiving break. You guys don't really get a break from this class, though, do you?
No.
Or Monday, Wednesday, so we're just rolling right on through.
Yeah, oh, yeah, we're getting cheated from, yeah.
Cheated from your break?
Mm-hmm.
It's not you're getting more for your money. You paid and you don't even have to take a break? No? It's all in your perspective, huh?
Yeah.
Don't remember the trick, it's not cake. It's hard. So it's x equals 2 to the y. How in the world do we do it? Make it is just make a table. You're totally right about that.
And then just, you're solving for x, so you plug in for y.
There it is. You plug in for y instead of x. Did you remember that trick? See, let me show you why. If I plugged in for x, you know we're going to plug in 0, 1, 2 like we always do, right? If I plugged in 0, 1, 2, nothing would work. Let me show you. For x, you got to plug them in for y because x and y have reverse positions in this thing. Why? What would be the problem? Well, if I look what will happen. If I plug in 0 for x there, I'll get 0 equals 2 to the y.
Is it because Hitler's a town?
No, it's not. That's what's the answer for y? What y could I put up there? 2 to what power would come out 0? Now you might think, well, 0. No, but 2 to the 0 is 1. It doesn't equal 0. There's no way you can put a power up there and make it 0. That's crazy. There's just nothing that does that. Nothing in a power makes the whole answer 0. A 0 power makes the answer 1, but nothing makes the whole answer 0. Jeremy?
Is that 2y? Is the y the actual power?
Yeah, I know. You can't hardly tell, huh? They didn't put it up very much, did they? Yeah, I know you, and I'm glad we're seeing that on the pro exam, so you won't be taken off guard on the real exam. Yeah, I wish they raised them up more. I'm getting this off test generator. I know you can barely tell that y is even up at all. If you look really close, you can see that the y is raised because the little tail doesn't come down below like y's normally would if they were on the level. So it's not on the level; it's raised. But yeah, it's barely, huh?
That's supposed to be an expert.
Yeah, that's a power, and yeah, that's important. Yeah, they should have made that higher up. Okay, so everybody see the x side isn't going to do anything for us. So that's when you go, oh, this one's reversed. Because what do you mean reverse? Well, don't we normally start with y equals, blah, 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 whatever? We normally start with y, don't we? We always get y alone, y's in the front, That's normal. Well, this one, they reversed it. They put x in the front. So that they've reversed things. You've got to reverse things too. Put your 0, your 1, your 2, your whatever on the y side, not the x. Then it'll be easy. So let's do the first one. X will be 2 to the 0. When y is 0, what's 2 to the 0? 1. Anything to the 0 power is 1. Next one. X will be 2 to the 1. What's 2 to the 1? 2. Next one. 2 to the 2. 4. See how easy that is when you plug? So you always plug in to what's inside the formula. The y is in there. All right, so now let's do some dots there. Here we go. Over 1, up 0. Over 2, up 1. Over 4, up 2. See how it's doing this kind of thing?
Let's see.
Wow, they're kind of close, aren't they? So what we got to do is we got to look super close and find out which one really has these points, because they're all kind of close. So this is a good lesson for what we're going to need to do on the real exam. So what I would do, guys and gals, is I would just hone in on, say, like 2, 1. They all have 1, 0. See how they're all going through over 1 up 0, over 1 up 0, over 1 up 0, over 1 0. They've all got the over 1 up 0. But who really has the over 2 up 1 right on the money? It's got to be right on the money. Over 2 up 1 is right here. He missed it. He's out. It's not A. Over 2 up 1, he missed it. It's not B. Over 2 up 1, he nailed it. Over 2 up 1, he missed it. It's C. See, only C went through over 2 up 1. That good? See how we did that? So just look for that 2, 1 point. So just reverse X and Y, because they've reversed X and Y in your table. Put the 0, 1, 2 in the Y side, and then use the 2, 1 point to find which one's really right. Questions on that? Do a couple more. All right, so try number 6 there. Yeah, did everybody get one of these? Anybody else need these? No? Let's try number 6 there. All right, what do you do? Everybody remember, what do you do when you're solving a log? Get rid of it. Excellent. When you lose the log, base stays the base, other two switch. Right, so cross off that log. That's pretty much what we always do. When we see logs, we cross them off, don't we? We just get rid of them. And when you lose a log, base stays the base, other two switch. Right? Whenever you lose a log, you cross off a log. Base stays the base, other two switch. So the 9 stays the base, the 9 stays the base, and the other two switch. Instead of 9 to the x, it's 9 to the half, and the x goes over there. Is that good? And okay, but what's 9 to the half? What do we do with that?
3.
Is that half of 9? Is that 4.5? You do the calculator? Yeah, a lot of your calculators will just do it straight. That's good. If you're not sure, remember how to convert it by hand? Scooby-Dooby-Doo. Right. The little denominator. Scooby falls through the denominator and into the trapdoor there. Remember? Fractional powers. The denominator swings into the hook. Really important on this test. You'll be tested again and again and again and again that you know that. Fractional powers mean roots. Fractional powers turn into roots. How so? The denominator, see the 9 to the 1 stays there. 9 to the 1, that's still 9 to the 1. That hasn't changed, right? The numerator stays put. But Scooby-Doo falls down through the trap, swings around into the hook. Right? So remember that fractional powers denominator swings into the hook. So it's square root of 9. So it's 3. Square root of 9. Fractional powers mean roots. Try number 9. Number 8.
7. Number 7. 7.
Oh, I'm skipping 7. Let's do 7 then. Yeah. Better do 7. Do 7. Number 7. I gave you a mantra, because I gave you a mantra for everything. I gave you a mantra when you look at a couple of logs. What are you supposed to do? I called it the log countdown. So there should be 2 logs, next line 1 log, next line no logs. 2 logs, 1 log, no log. So as you're looking at that, think, okay, number 7 I'm talking about. There's 2 logs right now. Do something to make them 1 log, do something to make there be no logs. So log countdown. 2 logs, 1 log, no log. Okay, so 2 logs. How do we make, so it's the log countdown. So 2 logs. Next line there should be 1 log. So how do you make those 2 logs? This out of the way. How do I make those? Oh, I just hit the wrong button there. How do I make these 2 logs into 1 log? Yeah, because adding, easy, that's the easiest math operation there is, adding, right? First thing you ever did in math, you're a little kid, add. Easy job for 2 logs will be a little harder job for only 1 log. So if you just have 1 log, base, now the 9 isn't going anywhere, right? The 9 is just like glued to the G. It's not going anywhere. That's the base. Never mess with the base. Well, unless you lose the whole log. Well, even then, the base stays the base. So we just never mess with the base, do we? So that base just stays put, and it becomes x minus 2 times the other x minus 2. What if there was a minus in the middle instead of a plus? Then it would be x minus 2 over x minus 2. Remember, minus becomes division. They both make things smaller, subtracting, dividing. And adding and multiplying go together, because adding and multiplying both makes things bigger, right? So the base stays the base. The 9 stays put. The other... Oh, wait. Well, I'm sorry. I'm doing the wrong thing. The 2 logs become 1 log. Like that. Adding becomes multiplying. So 2 logs, 1 log. Next line, you should have no logs. Remember, it's a countdown. 2 logs, 1 log, no log. So how do you now go to no logs? You know, lose the log, right?
Lose the log, base is the same.
Cross out the log, base is base, other 2 switch. So lose the log, base stays the base. Other 2 switch, what do I mean other 2? Everything else. All that x stuff and the 1 switch. Instead of 9 to all that x stuff, it's 9 to the 1. And all that x stuff goes over there. Good? Everybody good there? When you lose the log, whenever you lose log, base stays the base. Other 2 switch. Okay, now what? Well, now you got to FOIL that out. What do you got? X squared minus 2x minus 2x plus 4. X squared minus 4x plus 4. What do you do with that thing? Got to get a 0. We're going to try to solve that. Yeah. So subtract 9, right? Whenever we see x squared, got to get a 0, don't we? So subtract 9 from both sides. Like that. Factor it. What multiplies to be 5 adds to be minus 4. What times what is 5? 5 and 1. And how do they make negative 4? Sign in the middle, sign in the bigger. Negative 5 plus 1 makes negative 4, right? We good to there? Am I going too quick? A lot of steps here, huh? So whenever you see x squared, you always get a 0, right? So whenever x squared shows up, that's a sea monster, and rearing its ugly head. Whenever you see x squared, you get a 0. Factor, minus 5 plus 1, because that multiplies to be negative 5, adds to be negative 4. And now what are the answers? Yeah, it's positive 5, negative 1. Opposite, remember, parentheses to the answer is opposite, opposite. Because you said each one equal to 0. Right, so you might, at this point, be tempted to go, okay, I don't see that answer.
You have to check for...
Yeah, remember you have to check. You have to check log ones. They're kind of a pain.
You never have a negative and a log, right? If you plug the negative 1 back in.
Right. Yeah, so the 5, so if you go, and the check is easy, but you got to remember to do it. Go back to the beginning, put in the 5. First off, you put a 5 in right there. That's 5 minus 2, that's positive 3, that's fine. As long as the inside of the log is positive, not 0, not negative, it's okay. 5 minus 2, that's good. But what about the negative 1? Negative 1 minus 2 is negative 3. No way. Throw away that negative 1. He's a false answer. So 5 is the only real answer. Did you track with that? Remember all those steps for solving logs? So 2 logs, 1 log, no log. And then we had x squared, which means get a 0 factor. And then it's opposite, opposite from the parentheses to the answer. And then we had to check. And it's a quick check. Just make sure whatever you plug in doesn't make the inside of a log negative. Now, again, I don't want you to think, don't think this thought. Don't think, Mr. Heron said there's no negative answers to log problems. That's not what I said. That's not the truth. For example, you could have x equals positive 1. Would that be a valid answer? If I had gotten it, I didn't even get it, but if I'd gotten x equals positive 1 and I checked it, would it check okay? Would we say, hey, it's positive, so it's good? No. If you put positive 1 in here, it would not be okay, because positive 1 plugged in minus 2 is negative. So I would have thrown that one away as well. So it's not just that all positives are good, all negatives are bad. It's what they do when they're plugged in. It's not what they are in and of themselves. It's what they cause to happen when they're plugged in. Right? That makes sense? So when you plug in 1, it would be bad, or negative 1, it makes negative inside the log. So that's why it's no good, and 5 is a keeper on that. Well, guys, why don't we stop there, huh? We did 7 of them. That's pretty good.